was yeah, but just a couple of things on the agenda was basically just to follow up a couple of the things that we discussed at this Monday session, I think, on the L1 or in the second day. Yeah, mainly basically the more immediate question of where the proofs should go and whether or not we actually want to go through with what we discussed there, which was adding the proofs to the transactions in the mempool and like some other details of how precisely they should work. And yeah, and kind of I guess this is on the more practical side, like basically maybe just agreeing on concrete steps of yeah, where should we go from there? If this is what we want to do, like what do we need to do? Is there any blockers? And so on and so forth. And then yeah, the other question was more like speculative, I guess, and yeah, more of a kind of yeah, possibly relevant to Fusaka, but like not, I guess, really as immediately important to like do something concrete about. And yeah, basically just discuss this question of hello,
Can you hear me?
of column versus cell propagation. Yeah, I don't know. Is there any preference? Does anyone have any preference on where to start from? Or Dankra, do you want to also say if you specifically have other ideas on yeah, other things that we could talk about other than what I put in the agenda, or should I just start with one of these topics and go from there?
Hello. Can you hear me?
Yeah, yeah.
Good. Okay. Sorry. That's we're getting this to work. Good. Cool. Right here.
Very bright.
Sorry, I missed what you already said, Francesco. Did you introduce?
Yeah, so yeah, I was just basically saying I put in the agenda two things like that kind of follow up on the last session of the other one, or indeed, like one is this question of do we want to put proofs in the transaction, which is sort of what we ended up mostly agreeing on at the L1 R&D, and yeah, just kind of discuss that further. And then this other question I just mentioned to you also of columns versus cell propagation. And yeah, I have this small doc and I can kind of go over some thoughts. And then I don't know if you have something else that we should discuss.
No, I think I was just mainly gonna go over, I think, like the things from what we discussed in Vienna. So like the vertical versus horizontal sharding in the mempool. Then I think your idea of using cells makes sense. So I think like it would be great if you presented that as well. Yeah.
Yeah, I mean, if you maybe if you want to go ahead and start with the Vienna things, then yeah, let's just go from there.
Mm-hmm. Cool. Okay, cool. So like in actually quite a while ago now, in September, we had a workshop in Vienna, and we're like talking about distributed block construction, and especially how that would work with blobs. And we try to like go through everything from a bit more from first principles. And So we wanted to like look at how everything works together. First, how do we have a sharded mempool? Second, how do we get distributed block construction? And then also how everything fits with inclusion lists, which are also like an important feature of a future design. And I think like one of the big questions in the past had always been like, do we want a horizontally or a vertically sharded mempool? So a horizontally sharded mempool looks like this. You basically have you have different blob transactions being in different mempools, indicated by the different shades of gray here, and then their blobs would basically be in one piece in that mempool, and each node only listens to some subset of those mempools. And in contrast, the vertically sharded mempool looks like this. You have all the blob transactions in the same mempool, like everyone still knows about all the blob transactions, but we split up the blobs so that they are now like basically split up into pieces. Just basically how we do it for data availability sampling, and everyone only like sees a subset of the blobs. And yeah, basically, I think like for a long time we thought, oh, like horizontally sounds much easier. Let's just do this. Like it's like there's no huge changes other than that we like have to subdivide the mempool. Like we have to split up the transactions somehow. Like we can do that, for example, by sender addresses or something. That seems doable. But there is basically there's one big problem with it, which is we can't really figure out a way in which a block builder who doesn't listen to all those mempools knows which blob transactions they can include. So it's quite it's quite tricky to know if you can include blob transactions. Whereas like the vertically sharded mempool at least gives you some indication. Like you can basically look at the samples that you listen to, and in that way you can figure out which transactions are likely to be included. It's not perfect because sampling doesn't give you perfect like certainty, and that creates like separate challenges, but it is like much better than knowing nothing. The second thing is when you start thinking about, okay, like the second thing with distributed block building, what you want is that you can somehow put these samples onto the sampling channels, right? So we have the in PIDAS, we have the subnets for data resampling, and we basically need to transfer whatever our sharded mempool looks like into these subnets. And now, if you do that in the horizontally sharded mempool, well, like it's there's quite a poor alignment between the two, because like you have like some mempool that you listen to, and you have some sampling subnets that you listen to, and basically only on at those points where there's an overlap, basically where they cross, can you contribute to distributed block building. Whereas in a vertically sharded mempool, the alignment is perfect. So you can just say your samples for the block and your samples for the transactions are the same. So that means that everyone who does listen to the mempool, which doesn't have to be everyone, but everyone who does listen to the mempool would already have all the samples from transactions that are in the mempool. So that's pretty elegant. It's actually like a double saving. Like basically it means that in the case where you only include transactions from the mempool, everyone who listens to the mempool already has all their samples. So that's like basically as good as it gets. And And like those that don't listen to the mempool or for some reason like miss the transaction only have to be like filled in like a very small number of samples. So I think like Francesco just had an idea, so he'll come to that later, which I think is like also like a very good extension of this. Right, so this is like basically the reason why, at least like as a final goal, it seems much better to do the vertically sharded mempool. There is one problem with it though, that makes it a bit more difficult, which is that if you like, you basically have this problem that you have this chicken and egg problem. Like if you have like one piece are the transactions and the other piece are the samples, and like you can always, as an attacker who wants to DOS the mempool, just provide one of the things. Like basically you can like send some samples but don't send any transactions. So you get to spam the network, but like there's no transactions, so nothing happens. And like or you can do it the other way around, and both of these are annoying. And there's no like in the traditional mempool, we have like some protection against this because any transactions that's propagated in the mempool can also be included. So there's at least some like hazard for the attacker that they might have to pay because the transaction just gets included. And we don't have that guarantee here. And if you try to get that guarantee, for example, you could say, oh, I only propagate transactions and samples when I have all the transactions and all the samples. This doesn't work because you basically like two neighboring nodes don't necessarily, or are very unlikely actually, to have the same samples. So basically you would like make the propagation impossible if you had this very hard requirement. And so the way we figured out how you could do that is if you basically restrict who can post transactions in the mempool. And it turns out there is a rule that basically would like provide very little downside and still like probably like allow us to protect the mempool from DOS if we like basically can limit the number of addresses that can send transactions on this mempool. So the idea is that you basically only allow those addresses that have already created some number of block transactions over the last week to send new ones. So since rollups, most of the time, it's always the same addresses that send the transactions. Any rollup would like basically, be free to just keep creating block transactions because like they are always in the set of addresses that have created block transactions over the last like day or week. Yeah, depends what we want to do here. And then like this of course creates the problem. How do you enter a new address into the pool? I guess like you could obviously always do that by bypassing the mempool and just like using Flashbots protect or something to get a transaction in. But like if we want to be super purist and make sure that like everything can be done through the mempool, we can also just say you can like burn a small amount of ether to enter the set. And it doesn't have to be very much, like say 0.01 ether. And then like you also enter this eligible pool of addresses that can send these transactions and samples. And so the why this works is basically like you now have like a finite number of addresses, like some thousands of addresses that can send them. And basically as soon as one of these addresses does something bad, like for example, intentionally seems to send only transactions or only samples, or seems to be like sending some samples and some transactions that don't match, then you can just blacklist them and stop them from doing this, and the mempool can basically be protected. But yeah, this is the main downside of the vertically sharded mempool, but like everything else like is aligns very well. in terms of how you use this for distributed block building, so one, like the most naive way would be you just use your local information, your local sampling as a node to determine whether a transaction is available, and then you include that blob and or the blob transaction, and others will fill in the samples. So unfortunately, when you have many blobs, this is not good enough, because like using local information, you can, for example, determine, oh, there's a 95% probability that a blob is available. But like the problem is if you include 10 blobs and they're only 95% available, then you're already at almost 50% that one of the blobs is unavailable. So like this is like this makes it relatively easy for someone to like DOS you in terms of making you create a block that doesn't have enough or that does have an unavailable blob. And so like you do need to use some additional mechanism to determine the availability of a blob. I think Francesco in the inclusion lists will come to one of these. But basically, you can use voting even with a relatively small number of votes to basically find out that others like also agree that a blob is available, and then you can safely include it. Yeah, I think like this is the summary of what we found on sharded mempools. Happy to take any questions. Otherwise, I'll hand it to Francesco.
I just wanted to ask about, so it wasn't clear to me when you were saying about these percentages, was the model here about the local view. So what's the difference between blobs I'm seeing a number of blobs. What differentiates one from another?
So basically sampling, like for example, if I sample a certain number like of samples, then I only get a certain probability that a blob is available, right? I don't get 100% unless I take 50% of the samples.
Okay, so it's so are we in the model that we are getting a few based on the split, was that vertical split, horizontal split? Anyway, based on columns, and then we are sampling into the ones that would be selected, or?
So everyone basically the idea of the vertically sharded mempool would be that like I use the same samples that I will sample for the whole block, and sample the blobs according to that from the sharded transactions. Does it make sense?
And then I would on every blob I would get individual results.
Yes. So on every blob you get a result, like whether you get all the samples or not.
Yep.
And so that gives you some indication locally if that that blob is available.
Okay, and then the probabilities, the statement was that even if I would have like all your sampling succeeds on all the blobs that you would be willing to include, then you would still not be sure enough, or?
If all the sampling succeeds.
Or yeah, I was just, yeah, maybe I don't have the mental model yet.
So if all the sampling, so the problem is basically like, well, it depends on the number of samples, but say you do something like 4 samples for a block. Right. Okay, so this would be relatively low, but like then you have like 2 to the minus 4. It's like each like I can send transactions where like less than 50% of the samples are available, or like just under 50%. And with 2 to the minus 4, you will individually see those as available, right?
Yeah.
2 to the minus 4. Okay, so now the problem is, like, let's say you do that for 10 transactions.
Yep.
And each of them you do like a different random subset, right? So
Yep.
each of them has a chance of tricking you into thinking it's available independently.
Yeah.
And so basically, like, the probability is just like add up and like.
Yeah, no, that's good. Okay.
Okay, cool. Francesco, do you want to go ahead?
Yeah, I guess before moving on, while we're on the topic, let me just say like just a couple of words on these other related approach. I think I already put it in the chat, but here it is again. Yeah, so it's basically, I think, I don't remember, maybe I already mentioned this during the L1 R&D workshop, but anyway, basically the point is kind of starting from the same set of ideas around a vertically sharded mempool, but trying to think of like a different way to basically regulate what can come in. And basically part of the idea is just to really have like a strong guarantee of you can only have these many things going through the mempool. And yeah, basically the document kind of just talks about this idea of blob tickets, which is you could really auction off in some way. And like I'm talking about a specific way to do this as well, but it's really one out of, I don't know, very many that you could try to approach this problem. But yeah, auction off basically the right to send a blob in the mempool, but not only sending a blob in the mempool, but also then actually getting that blob included. Like you would only be able to get a blob included if you own a ticket corresponding, basically. And the idea of why you would want to couple these two things, like mempool access and inclusion, for me was basically that if you only try to auction off these mempool slots, you would, I mean, in some sense, mempool access is kind of, it's not very valuable by itself. You could always try to bypass it if it is bypassable. Like you could just go through a builder, and yeah, so the default state should be that basically L2s just don't go through the mempool; they just send directly to builders. And so yeah, basically trying to avoid that is why there's this like coupling of. I mean, you could still avoid the mempool, but the thing is, once you've already paid for inclusion, like you have to buy this ticket, you kind of might as well use the mempool. Like it doesn't cost you anything extra, as opposed to really needing to buy the ticket for the mempool. And yeah, and also just generally makes it harder to like basically prevent usage of the mempool to people that actually want to use it, because then you actually need to pay for the tickets and for inclusion, in which like it only makes sense for you to do if you actually have blobs that you want to get included. And so yeah, basically this kind of talks about how this would be structured, and a bit about the auction, and but a lot about the what do you do with the tickets in the mempool, like the kind of how the gossip topics could be structured, and things like that. But yeah, other than that, I mean, once you have these tickets, like then it's all quite similar to kind of what Dankrad was describing, just in the specific setting of like a CL based mempool. Yeah, I don't think it's worth going into the details too much. Just kind of wanted to flag it as like a related but slightly different approach. And then you can look at the post, I guess. And then yeah, if there's no questions on this, which okay, I guess I'll wait like a few seconds in case there are. But yeah, if not, I would move to this first question that I put on the agenda, which is like, so to recap, like kind of what we discussed in the breakout at the L1 R&D, like one of the things, and this is a document where I took some notes on what we discussed. So this is the first point there, which was basically something that was really a question coming from the previous distributed block building call, which was where should the proofs live? And like it's, I didn't really want to share the screen. I mean, I can do it, but sure, I'll share the screen. Okay, do you see this breakout notes? Okay. Yeah, so I mean, this is the kind of point that I would go over now. Like basically, yeah, the question that was that came up in the previous call was like, where should these proofs live? I mean, right now they would be sent just along the column sidecars. And specifically in the context of distributed block building, the issue that they present is that you'd have to compute them once you get the block and now you want to kind of construct the column associated to it. Now you have to compute the proofs, or you could pre-compute them as well. So that was, I guess, one of the approaches. And also just in general, I guess, even not in the setting of distributed block building, but just regular block building, you basically have to do this computation or pre-computation as you're doing the building. And I mean, it's nothing like incredibly prohibitive, but like it felt like it's an extra challenge to putting in the actual like critical path of building, especially in the context of like distributed block building, where it's really a bit even more time sensitive. And yeah, so it felt like it's something that really should be put on the transaction senders instead. Like it really can happen in this kind of distributed, like non-time critical part of the pipeline. And so, yeah, the specific proposal that we discussed in the L1 R&D was this one where basically transaction senders compute the cell proofs and then they just add them to the network wrapper for blob transactions in the YEL mempool. So yeah, this like in terms of like added bandwidth is not that much. It's just these like extra few kilobytes. And so some other times that this has been discussed, the idea was like you would also send the blob extended. So like you also pre-compute or like compute the extension and just send like this full extended blob so that you can then have all of the proofs and do the full verification. So one thing that was different here is basically saying, let's not do this so that you don't double the size of what you're sending in the mempool, but let's just compute the extension. So this would happen like at the level of you send the transaction to someone, they would immediately then compute this extension locally, like the YEL would need to do this. And yeah, part of the why is just that it's just fast compute, but it's a lot of bandwidth to send it. And then, yeah, basically once you receive it, you do this computation and then you would immediately verify all of the proofs because you get all of the proofs, not just like the proofs for the whole extended blobs. And you would actually do this before forwarding so that it's there's no kind of weirdness around unverified things that you're forwarding. Yeah, and basically, I mean, at least in the previous in this session, the L1 R&D workshop, there wasn't really much of any points raised against this. So I guess one question here is like, with some time since the first time that we discussed this, are there other things that we should be concerned with that we didn't think about last time? And then the second question is like, assuming that this is not the case, then where do we go from here? I mean, I guess some of the things that are not right now in place is that you would have to do proof verification on the YEL, which I guess that's not something that YELs do right now. And yeah, I mean, just generally like these changes in the kind of YEL mempool Yeah, like putting the proofs in the wrapper, like et cetera, et cetera. But yeah, I guess just wondering now, like, what are things that we should, yeah, are there things that that we need to discuss? Is something that we can kind of just go ahead and do? Yeah, basically, like, where do we go from here? So yeah, I don't know if anyone has any thoughts here, or concerns, or I mean anything. Okay. Sounds good to at least one person.
What was the proof verification time?
Right, yeah, I didn't talk about that. Yeah, it's so this is 16 milliseconds. So yeah, one thing
Okay.
that we talked about in the, I mean, and okay, I guess this is on some specific machine, which I don't know. You can check the benchmarks here, I guess. I don't remember what machine it is. And the benchmarks are also old, but I think this might be reasonably up to date. Which one is this?
It was probably an Apple M1 CPU.
Okay, all right, then that's it. But yeah, like, so
Yeah.
one of the things here that was concerning last time that we talked about this in the previous call was like, oh, this is too long for transaction propagation. But then, yeah, talking about it again with Maris and Peter, and I think also at the session, just this doesn't really apply quite in the same way because of two reasons. Like, one is just that we don't have that many blob transactions going around in the mempool, so it's not the same thing as the regular transaction pool. And yeah, also just the blob transactions are heavy. And so this extra kind of verification load doesn't really, I mean, relative to like the fact that they already like take a while to send, it doesn't really tip the scale too much. So yeah, this kind of seemed to be like an okay number, even I guess with this extra thing of extending the blob.
Yeah, so
Yeah.
I think that the two things to consider there, one is the actual delay, kind of stolen forward delay that you're adding. And I don't think I mean, in the mempool, that shouldn't be a problem. If you have five, I don't know what hop count we have usually, but if you have, let's say, 5 hops, we are adding 100 millisecond to the whole thing. So it's I don't think we go much beyond 5 hops on that. So it's just the delay itself is not a problem, and then there is the overall computational cost that we are adding to the ERs, which are already suffering or whatever, and that's maybe to think of what's there and what can go wrong there if there are many blobs in the mempool for one reason or for another.
Yeah, I
But
mean, we have to treat these totally different than kind of we do today. Because 16 milliseconds is on a very fast processor. I think realistically it's probably closer to 40 for a lot of people.
yeah, but
What do
even
you
that,
mean by we have to treat them differently, as in like have more rate limiting of blobs in the mempool, or
I think we just have to be very cognizant about accepting blobs into the blob pool, maybe even more so than we already are today, because the verification is like on the same order as it takes to propagate the blob to the peers. And that's just like for one. So if we have to do this, this is for every blob in a transaction. We might have to do this several blobs.
it's
yeah, I mean, actually, if you have multiple blobs, I guess it's better because you can do even more batch verification. But yeah,
You can batch the verification across the blobs.
I think so.
Okay. Yes, you should be able to do that.
yeah. So there are all these kind of strategies of batching and so delaying batching and amortizing, which helps in general. But still, I what I would like to understand is whether the kind of the overall CPU consumption that we are adding can hurt. How many blobs can be coming in? not too many, I suppose.
I mean, not too many right now, but if we have peer DOS, like what is the expected blob per block target that we'll be looking for?
Okay, but yeah, but so that's one point is was the kind of the blobs throughput, and then after those which are going to the block, but then this is the mempool still, right? So it's gated to some extent based on this previous document, but still you can have blobs which are not just not making it, and those are also adding CPU cost everywhere. So yeah, but if we would have 100 blobs, you would burn your CPU for 1.6 seconds just for this.
I mean, with 100 blobs, like we would almost definitely not be doing all of this, or like regular nodes would not be doing all of this. You'd only, well, I guess I don't know if do you mean 100 blobs in a mempool or 100 blobs as like in general? But either way, I think it's like we should not be getting to having 100 blobs in the mempool unless we are close-ish to 100 blobs target. Like it's really, yeah, I mean, I think the mempool has to be quite strict with blobs, that there cannot be a lot more blobs going around than actually land on chain. So yeah, I think, I mean, in the short term, before peer DOS, I guess the blob counts we'd be dealing with is like maybe 10 to 15 or something in the mempool per slot or something like that. After that, maybe higher, but eventually with some form of sharding. And this form of sharding, I guess, if we go the route that we were kind of discussing with Dunkra before, should involve some more explicit constraining on the mempool, like on what can enter the mempool.
Also, that many blobs, you could potentially parallelize this in some way. So like across 4 or 8 cores, you could do like multiple batch verifications at the same time.
Yeah, that's what I just wanted to understand the kind of the single core CPU time that you are burning on this, and then you can, the more cores you have, you still use the power, but you are you have the resources. Yeah, but I don't think it's like with the number of 10 blobs, this shouldn't be a big burn of CPU.
Yeah, and I guess the other thing is like the more dense blobs are in coming in, like basically the more blobs per second you get, the more batching you can do without actually slowing down propagation. So that's also, and that's not just using like multiple cores, like you can parallelize, but you can also batch, and that's just like kind of a pure saving. So yeah, I guess things are not quite as bad, even at higher blob counts.
Yeah, I see the compromises. So we are in the mindset of basically every blob which is coming into the mempool is going to the block, right? That's the kind of the mindset. That might not be true. If that's the mindset, we are burning the CPU here or burning it later. It's just a question of, actually we are better burning it here because we have more time here, so you can do more batching and you can amortize more. So until that's true, that the mempool is basically full of blobs, so sooner or later the blobs from the mempool will be on chain. You would basically burn the same CPU then, or even more.
I mean, I guess by default right now, you'd still then eventually do the same verification on the CL, but in like, I guess in a different format, you'd be verifying columns instead of blobs, but still you replicate the same effort. But yeah, we could try to limit that.
Yeah, that's true. That because of the client division, you would just replicate it once more. But I mean, still, I mean, if we can burn it on one side, we can burn it on the other side. I mean, the CPUs are, it's not like one can be an order of magnitude bigger than the other. It's the same, except if for some reason there can be a bunch of blobs which are not making it to the chain.
Yeah, so actually this like kind of mempool sampling post that I mentioned with blob tick. It's like part of the idea is really this, like to make sure that there is an equivalence between what goes on chain and what goes in the mempool, and so there is no kind of yeah, there's no wasted effort for things that don't end up on chain, and also do not replicate the effort, like just saying that you only do things, like you only do sampling, you only do verification, you only do propagation in the mempool, and then you don't have to do it again. Like there's no then separate kind of path to propagate columns afterwards. It's just, you know, the mempool sampling / propagation is the path, basically. But like, yeah, this is all kind of more speculative and more like research land, I guess, than the the more concrete thing. So okay, I guess yeah, I guess with this we are at, it sounds reasonable, but like should be I don't know, maybe like investigate a bit the kind of resource usage for proof verification, and like possibility of batching that at different blob counts and things like that. And I guess generally, I mean, this is independent of this, but like we should I guess think more carefully about what does in the short term, like the next year, or you know, however long until we have these different ways of thinking about the mempool, like what does the relationship between blobs in the mempool and blobs on chain look like, even like with an adversarial mindset, and like what can we do to kind of improve that and like have better worst case guarantees on that, I guess. I don't know if there's anything else to say on this for now.
Did for this proposal, is it like what is the relation with blob tickets or any of these ideas about like creating a system for accepting the pool transactions? Is it separate?
So I guess it's separate in the sense that, yeah, like with a vertically sharded mempool, for one thing, you would have the extension necessarily be part of the mempool, because you already want to be doing sampling in the mempool. So there wouldn't be such a thing as like you cannot save the cost of sending the extension, because you're not just sending a blob, you're really sending like all of the samples kind of separately. So that's one thing. I guess this aspect just does not apply to like a vertically sharded mempool. Yeah, and I mean, I guess the aspect of like proofs being computed at the transaction sender level, that does apply. Like you'd be sending as a transaction sender samples with proofs, so you necessarily have to do the computation yourself to be able to send something. So yeah, that's kind of the relationship, I guess. It's not super relevant, as in like this is not a step towards that. I guess this aspect of like proof verification be done at the sender level does apply to both, but I guess in my mind this is more like, to me this seems like possibly the right way for things to work in the current mempool, and especially with respect to distributed block building. Like it seems to me like it would be better if proof computation wasn't done in this like path of distributed block building, and this seems to me preferable to like pre-computation. But yeah, it's not so much of a trying to make a step towards something else. It's more just like maybe this is a good way to do things for now. Okay, yeah, if we've exhausted this topic for now, at least, yeah, we can keep these things in mind. And quickly just wanted to, can you still see my screen? Yeah, seems like it. Yeah, basically maybe quickly go over this cells versus column gossip thing that we also talked about at Del 1 R&D. So the point that was raised was basically it would be nice maybe for a distributed block building to have the ability to not only gossip full columns but cells, because basically if you can only gossip full columns, you need all of the blobs in order to make any meaningful or like any contribution at all to this like distributed block building process. Like if you don't have all of the blobs, you cannot construct a column. If you have just one, like it doesn't let you do anything. And so if we could instead gossip individual cells, you could, even if you have, you know, 1 blob, 2 blobs, 3 blobs, however many, you can gossip the cells corresponding to those in the topics that you're in. So yeah, I mean, one question I had, generally speaking, is like, sure, this sounds nice, but then in practice, does it actually make the system perform better or like meaningfully more robust? And like, it's not entirely clear to me that that's the case. But yeah, and I guess just my thinking is like, in practice, it's mostly gonna be like nodes with a bit higher bandwidth that really end up like, you know, meaningfully contributing to distributed block building, and they're probably gonna have all of the blobs. So yeah, that's one question, especially in the short term, like when we're not talking about, you know, crazy blob counts. But yeah, so that's kind of one question, is like, is this worth doing, particularly like in Fusaka, let's say, like if you really were talking about this as like a, you know, we want to change the current peer DOS spec since we have more time. So yeah, that's one question. And then the other question is like how exactly we should do it. So one design that I've thought about is this, like basically having the same kind of gossip topics as today, like basically these like column gossip topics, but where like you now don't gossip the full column, but individual cells. And like a cell basically just looks like the same as a column today, except that it has like only a single cell and a single proof. And it has basically this. So I mean, there's many ways you could do this, but playing around with it a bit, like this was the one that made more sense to me. Basically to have this like KZG commitment sidecar. That's something that basically it's corresponds to the sort of inclusion proof material that exists today in columns. So it's like the sign header, the commitments, and then the inclusion that shows that the commitments are contained in the header, or like in the block ultimately. Yeah, so this is like the thing that kind of allows the column sidecars to travel by themselves, basically detached from the block, and like resolves all of these like equivocation questions and all of this stuff, and doesn't require the columns to be signed. So yeah, but the annoying thing would be like, if we included all of this with each cell, that would be like a crazy overhead, like it just wouldn't work. We could do something milder, so we could include the single KZG commitment for this cell. So it could be like, you know, KZG proof, KZG commitment, and then the header and an inclusion proof that's just for that cell. It would still not be great. Like the header is like about 10% overhead on the cells of the size that they are today. And it would be even more overhead if we had like smaller cells, which could be nice to make sampling cheaper. So yeah, like the header by itself is quite heavy, and also then the inclusion proof would also be heavy. Like it would be heavier than the current inclusion proof, because it would be needing to show inclusion of a specific commitment as opposed to like the whole list of commitments. So there's like a few more like leaves that, or like nodes that you would need. So yeah, like both ways to kind of have an inclusion proof in each sidecar doesn't seem great. So what I was thinking is basically you could have this same kind of inclusion proof material that you have today, but you only send it once. You only send it like the first time that you send a cell, like considering a specific peer in this topic. The first time you send them any cell, you would send this kind of proof sidecar, and you don't do that afterwards. Like any other cell would just come with these things. So basically it's kind of the raw cell material plus the KZG proof, which is like the bare minimum kind of that you need, except for the indices, but they don't really weigh that much. So yeah, this I guess was the general approach that after a bit of like playing around with it made most sense to me. Like it seemed like the most similar in some way in terms of most similar to the current one in terms of overhead basically, and like in terms of like bandwidth overhead at least. And then the other thing that to consider in terms of overhead is just verification overhead. So yeah, like by default you kind of lose batch verification, which isn't great, but yeah, it seems like there would still be plenty of opportunities to basically introduce batching, reintroduce batching, things like waiting a bit and then you batch verify, you know, at fixed intervals, you batch verify everything that you accumulated, and you could do this across topics as well. I think today, if my understanding is correct, clients don't do this for columns, but like here you could maybe try to introduce this, like whatever cells you have, even across topics, you could batch verify. So yeah, these kind of things seems like there should be like plenty of way to like regain some of the efficiency lost by having cells instead of columns. Don't have too much more to say about this because yeah, it's really just like some thoughts, but I'm curious if anyone has like, I don't know, I guess general opinions on does it make sense to keep looking in this direction? Like, is this something, I mean, I guess one thing is just like, does it make sense in general? The second thing is like, does this make sense as a potential thing to do in Fusaka? Or is it like a crazy idea to change the specs with this? And then the other thing is, yeah, if you have any like specific thoughts more about the design or things like that.
So yeah, well, let me start from the end. So from the batching, the batching is so Nimbus is already doing similar kind of batching with the verification, where you basically you kind of naturally batch, because if you are lagging behind in your verification job, then you look at the queue, you have 20 pieces there and you just validate them together. And that kind of behavior is solving naturally many of the batching things. It's more of a engineering software organization saying that you should not, you know, launch the verification job on every single piece, but have the CPU resources allocated, and then when you are back to it again, you just look at the queue. Oh, I have 20 of them. I do them together. So that kind of handles this dynamically based on your resources. So I don't think that's a problem. Still, you have this CPU burn issue, but if we are going with these numbers, I don't think it's such a big problem. We are looking into that in the 2D large case, and then there starts to be more of an issue how much CPU you use if you do cell-based. For the cell-based distribution itself, these two questions: what to do with the headers and how to handle those, and whether to do cell-based distribution. And on the headers, I think we were floating that since quite a long time, I think, but we never actually looked into it. But I think the header would have to be basically present, like its own message. Start with that, push it out, everyone gets it, and then you have your local logic if you didn't get it. But from the propagation point of view, you just send it out. It's in that context, it's small.
By a separate message, you mean like literally like a separate topic, or within each topic?
Same
it's
topic,
a separate
message code header, and in which you just send it down. Everyone gets it. Fast diffusion. It has its own message class.
Is it much different at that point than just saying you just wait for the block? I mean, the header is obviously much smaller, but I don't know, in practice, does it matter super much in terms of diffusion time?
I mean, technically, I think the overall effect of bundling it with the first. Okay, so wait, what was the question? Well, is bundling?
Oh, like no, it was like comparing to if you just, let's say, forgot about the header and just said you just have to wait for the block in order to be able to verify and forward anything. Like the block will already have all the things you need. Of course, the block is heavier and like takes longer to propagate, but I wonder, yeah, I'm not sure like how big of a difference there is to wait for the block versus like wait for the header.
That's fine as well. It's just these are different overlays. So maybe because of the different overlays, it's redundancy. We are fine with redundancy, like we are doing it in for many things. So it might make sense to, just send the header redundantly ahead on this specific channel, so that it kind of propagates on the same structure and just goes ahead. But I don't think it would be a big difference. Better just wait for the block or send it ahead here as an extra redundancy. The header is small, right? You don't want to send it many times, but to send it out once on this channel, that won't change anything, like on the.
Yeah. I mean, sending it just once per topic, it's whatever.
It's the same size as yeah. Anyway, it's just small. So I think it won't make a difference, and then you are kind of having it just pre-propagate on this, and then you don't have that concern anymore. You still have to handle it in software anyway. The complexity of having it, not having it. What do I do? Do I queue stuff for how long? And then for the actual cells, if we are doing it like this, so we have the column, the sidecar as the main mechanism, and then this is like an add-on. I would do it with a pull logic. So I will not try to figure out the push logic to do this and that, because I think the clients would suffer with what's the right logic there, and I can't say what's the right logic there. I would just have this kind of I want mechanism in these channels, in which I know that others have these and I have those, and I'm personally in the situation that I'm blocked by not having that one cell, then I pull it. But I'm not pushing all the cells. No one is pushing all the cells, because then you are kind of duplicating the.
So what I was thinking actually was, you would not be sending columns, like you would only be sending cells. Do you see like a strong reason, if we did want to deal with cells, to not just deal with cells? If assuming like there there is no overhead from doing so, and like we've removed the header and kind of we figured out that batch verification works kind of well enough that way, like is there a reason not to just not have full columns gossiping?
So with sending just cells, I'm quite positive about that. There are two problems with that. One is a bit more of the overhead on the so you're suffering from a number of overheads, and many of them boils down to implementation related things. So on the NIM implementation, I have quite good results with sending a bunch of cells around. I would easily imagine many of the implementations would have problems sending that, although they are already sending a bunch of small messages, so maybe not. The overall effects of sending small cells would be kind of a mixed bag, because you are sending smaller messages, you have a slower forwarding delay, so your store and forward delay is smaller. On the other hand, you have more overhead because of the message overhead, the message ID overhead, all these kind of things. So you have this kind of strange balance. I think we can enable just the cell only behavior, but it would be a much longer testing. And because the normal testing is not going as fast as I was imagining, I'm a bit afraid of saying let's switch to the cell based, because it opens up maybe a bunch of implementation related things in the clients.
Yeah, so I guess one overarching question here is like, is this something that at all we want to explore for Fusaka? I mean, I guess we want to explore it, but like, do we want to open the can of worms in any way for Fusaka or no? And if so, maybe it makes sense to do it earlier because there isn't really, I mean, implementations right now are not working anyway. I mean, at least not like not in a way that where a DevNet can be stable. So maybe it's kind of okay to change the spec at this point. But yeah, I don't know. I don't have any strong opinion here. And also, as I said, I'm not entirely convinced that there are like big benefits to doing things this way in the short term, at least. Like maybe there's benefits to like future compatibility, and I think it might be nice that we generally experiment with cells. Like for example, eventually we probably want to deal with cells for reconstruction. Oh, speaking of which, Justin had this comment around reconstruction. Yeah, I just wanted to quickly say like, I guess you could think of it as like gossiping cells in vertical topics is in like column topics is for distributed block buildings, and gossiping cells in horizontal ones is for reconstruction. And it's just easier for us to start from the vertical ones because we have them. It's like something that we need versus like the horizontal ones is something that we would have to add, like the actual like we don't have row topics right now. But yeah, this is just a parenthesis. But yeah, so like it would be something that's nice to experiment with, and eventually probably want to do in some form, but it's not like super clear that there's huge short-term benefits to doing it. So yeah, I don't know if other people have opinions around this kind of aspects.
Yeah, just wanted to add still that I think it's nice to experiment with, and I see some people I think would be happy to experiment with it. Like I can imagine Anton would play with it. So maybe it's something that it's easier to experiment it than than change the spec and then force everyone to kind of go through. Easier to experiment in one two clients and just see where they go.
Okay, I guess we're at time, or past time. Yeah, I don't know if there's any last comments on this, or I don't know. Otherwise, yeah, we can just keep the discussion. I think if anyone has thoughts on like what's the right next step, if I don't know, yeah, there's like specific people that are interested in maybe trying things out, that could be nice. Yeah, it seems like I think you're right that like it would make sense to experiment with it. It would not make sense to now make like any kind of to take any like actual action, like changing the specs. So yeah, if there's anyone interested in experimenting with it, let's keep in touch. Okay, thanks everyone.
Thank you. Bye, everyone.
Bye.